In this video, we're going to do some extra examples solving logarithmic and exponential equations. Okay, so equations that have logs or exponentials in them. So let's start with example 2 here. So one way we can solve this is by making it so I have 2 logs in this equation. So I could make it so that it's 1 log equals another log, and then I can set the insides to be equal. So that's what I'm going to do here. So I'm going to add log of 21 plus x to both sides. So I have 2 log of x plus 1 is equal to log of 21 plus x. Okay, now I don't have log equals log right now because of this 2. So what I can do is move it to the exponent of this side. So that's log of x plus 1 squared is equal to log of 21 plus x. Now these logs, they don't have a base, which means that they're actually both base 10. So they're the same base and they're equal. That means the insides have to be equal. So that means that x plus 1 all squared has to equal 21 plus x. And now I have a quadratic equation that I know how to solve. So I'm going to expand it all out. So this is x squared plus 2x plus 1 is equal to 21 plus x. I'm going to move everything to the left. So I end up getting x squared plus x minus 20 equals 0. So I want 2 numbers that multiply to give minus 20 and add to give positive 1. So that's going to be plus 5 and minus 4. Okay, so though x plus 5 times x minus 4 should be 0, which means that one of these has to be 0. So x plus 5 is 0 or x minus 4 is 0. So that's going to be x equals minus 5 or x equals 4. So those are our 2 solutions. Now we should, because there's logs involved, we should check for extraneous solutions. So if we check x equals negative 5, we plug it into the initial. So that's 2 times log of negative 5 plus 1 minus log of 21 plus negative 5. So that's going to equal 2 times log of negative 4 minus log of 16. Okay, now log of minus 4, this doesn't exist. Okay, so that means that this is actually not a solution. Okay, so now we try x equals 4, and we have 2 log of 4 plus 1 minus log of 21 plus 4. So that's 2 log of 5 minus log of 25. And that actually is going to be 0 because the 2 can come up. So this one is actually log of 25, so 5 squared, minus log of 25. So I do get 0, so 4 is a solution. So x equals negative 5 is extraneous. So our only solution is x equals 4. Okay, let's try another one. So here we only have 1 log in our example, in example 3 here. So what we're going to want to do is solve for that log and then use the definition for the log to switch to an exponential. Okay, so I'm going to solve for the log first. So I'm going to add 9 to both sides. Okay, so that gives me 3 ln of 2x plus 5 is equal to 9. And then I can divide both sides by 3. So now I have the ln by itself. So ln, not of 25, ln of 2x plus 5 is equal to 3. Okay, now this is log base e, so now I can use the relationship between the logs and the exponentials to say that this means that e to the 3 is equal to 2x plus 5. Okay, and then if I solve for x, so I want a minus 5 on both sides. E to the 3 is just a number. Okay, you can compute it, but it's not a nice number, so I'm going to leave it like that. So that means that 2x is equal to e to the 3 minus 5. Dividing both sides by 2, I get that x has to be e to the 3 minus 5 all over 2. Okay, now we should check that. So let's check over here. So if I plug that in, I have 3 ln of 2 times e to the 3 minus 5 over 2 plus 5 minus 9 equals 0. So that's 3 ln of, so these 2's are going to cancel. So it's going to be e to the 3 minus 5 plus 5 minus 9 is 0. Minus 5 plus 5 cancel. So I get 3 ln of e to the 3 minus 9 is 0. Now ln of e to the 3 is actually just 3. So 3 times 3 is 9, minus 9 is 0. So this one works out, so that is a solution here. So that's going to be our solution. Okay, now let's try this one here. So here I've switched to exponentials, okay, but the methods are similar. So when I have one exponential, like I do here, so 10 to the x plus 1, what I'm going to do is solve for the exponential, like we did for the logs. Okay, so I'm going to get the exponential by itself, so move everything to the other side. So I have 1 over 4 times 10 to the x plus 1 is equal to 7. Multiply both sides by 4 to get rid of that 1 over 4. So I have 10 to the x plus 1 is equal to 28. Okay, now I can use the log rule, like the log definition, sorry, so switch to a log. So this is going to be the base is the base, so it's going to be log, so I don't need to write the base, but it's base 10 of 28 is equal to x plus 1, which means that x is equal to log of 28 minus 1. And if you compute that, you get approximately 0.447. Okay, now we didn't have to compute a log of any negative numbers. And our original equation was an exponential, which we don't have to worry about anything bad happening. So we know that this is going to be a valid solution. Okay, let's try this one here. So again, solve for the log. So I'm going to move the 7 over. So I get 3 to the x squared minus 1 is equal to 7. Okay, now this one is not base 10. Okay, it's base 3. So if I use the rule like I used here, the relationship, I'm going to get something that is log base 3, and I won't be able to compute that using my calculator. So what I'm actually going to do here is take the ln of both sides. Okay, so that's going to give me ln of 3 to the x squared minus 1 is equal to ln of 7. Now I can bring the exponent down to the front. So that's x squared minus 1 times ln 3 is equal to ln 7. And then I could expand the ln 3 through. So that's x squared times ln 3 minus ln 3 is equal to ln 7. Okay, add the ln 3 to both sides because there's no x in that term. So I get x squared times ln 3 is equal to ln 7 plus ln 3. Divide both sides by ln 3, and I get x squared is ln 7 plus ln 3 over ln 3. And then when I take the square root of both sides, okay, so that means that x is going to be plus or minus the square root of this number. So square root of ln 7 plus ln 3 all over ln 3. Okay, ln 7, ln 3 are both positive numbers. So this square root exists. It's going to be a positive number inside. So it's going to be approximately plus or minus 1.665. Okay, so and because we didn't get any bad lns and our original equation was an exponential, both of these solutions are valid. Okay, so here this gives us both solutions in the exact form and the approximate form. Okay, here's another very similar one. So we're going to do it very similarly. So move the 2 over, and I have 3 to the x squared plus 1 equals 2. So then I can take the ln of both sides. So ln of 3 to the x squared plus 1 is equal to ln of 2. Bring the exponent down. So x squared plus 1 times ln 3 is equal to ln 2. So then if I bring the ln 3 through, that's x squared times ln 3 plus ln 3 is equal to ln 2. Subtracting the ln 3 over, x squared times ln 3 is ln 2 minus ln 3. Dividing both sides by ln 3, I get x squared is ln 2 minus ln 3 over ln 3. Okay, now ln 3 is bigger than ln 2. So this numerator is negative, whereas the denominator is positive. So this number is negative. Okay, so if I just keep going with this, okay, so that means that x is going to be plus or minus the square root of that. Okay, so that is actually plus or minus the square root. It's going to be negative 0.369 approximately. Okay, which obviously doesn't exist because I can't take the square root of a negative number. So this equation has no solutions. Okay, so another one here. So here I have 2 exponentials. So we can use the same ideas we did in the last one where we take the log of both sides. So here I don't have, I can't put 2 in base 5 or 5 in base 2. So I can't use the method that we used earlier. So what I'm going to do is just take the ln of both sides. So ln of 2 to the x minus 1 is equal to ln of 5 to the power 2x plus 3. Now I can bring the exponents down. So x minus 1 times ln 2 is equal to 2x plus 3 times ln 5. Expanding everything out, I have x ln 2 minus ln 2 is equal to 2x ln 5 plus 3 ln 5. Okay, now I want all of the things with x's together. So I'm going to move this one to this side. Okay, so it's gone over here. And I'm also going to move the ln 2 to the other side because there's no x's in that one. So that's going to give me x ln 2 minus 2x ln 5 is equal to 3 ln 5 plus ln 2. Now I can factor out an x. So I have x times ln 2 minus 2 ln 5 is equal to 3 ln 5 plus ln 2. And now I can finally divide. So x is going to be 3 ln 5 plus ln 2 over ln 2 minus 2 ln 5. And if you compute this, you get approximately negative 2.186. Okay, which is fine. So I had no bad lns. I was able to compute all the lns. It doesn't matter that I get a negative number here because my original equation was exponentials. Okay, so this is a valid solution. And if you use this exact answer for x and plug it in up here, you'll get two things that are equal, surprisingly enough. Okay, so one more example. So we could have things in quadratic form. Okay, so example 13, it looks like I have two different exponentials, which I do, but I could, so I know 4 is 2 squared. So here I can write them in the same base. So I have 2 squared to the x minus 2 to the x minus 12 is equal to 0. And now I can switch the exponents on the first thing. So this is actually 2 to the x squared minus 2 to the x minus 12 equals 0. So if we let u equal 2 to the x, then I can write this as actually u squared minus u minus 12 equals 0. Now I know how to factor this. Two numbers that multiply to give negative 12 and add to give negative 1. That's going to be minus 4 and positive 3. Okay, so that means that if those equal 0, and one of them has to be 0, which means u equals 4 or u equals minus 3. Now if I switch back to x's, that actually means 2 to the x is equal to 4, or 2 to the x is equal to minus 3. Okay, now this one, 2 to the x is always positive because it's 2 to some power. So this one obviously has no solutions. So I definitely can't be a negative number. Okay, now over here I can actually solve this easily because 2 to the x, so 4 is 2 squared. So now they're in the same base, so I know that x has to be 2. The exponents have to be equal. But if you wanted to solve this, you could take the ln of both sides and solve for x that way as well. And you should also get, actually maybe let's do that. So or we have 2 to the x equals 4, so that's ln of 2 to the x equals ln of 4. Bring the x down, so x ln 2 equals ln 4, which means that x is ln 4 over ln 2. And if you actually compute that, you should get the exact answer 2. Okay, so here our solution is just x equals 2. Okay, so if you plug that in to the original, you should get something that makes sense. So that is a bunch of different types of equations and how to solve them that involve log and exponential functions.